Well, tonight new pictures showed damage to Yellowstone National Park after an explosion that happened last month. Now, Yellowstone is calling on citizen scientists to help them understand what exactly happened. No one was injured, but park officials surveyed the damage. The boardwalk used by parkgoers was destroyed, and the area was shut down to visitors. Total chaos was evident when Yellowstone National Park sounded its alarm system. What caused them to sound this alarm is shocking the world. Well, David, scientists at Yellowstone tell us that this was a random event, without warning. Still, they are investigating exactly what happened and what it might mean for the future of this area, making everyone question the safety of the park and even the world. The attempt to protect its visitors and even workers was as a result of powerful, life-threatening earthquakes that shook the whole park and its environs, risking the eruption of the Yellowstone caldera. What caused these earthquakes is going to survive this natural enemy. Join us as we explore the world of parks, earthquakes, and volcanoes. The park sits on a supervolcano. It tells us that there is activity in this supervolcano, which erupts roughly every 600 million years, and the last eruption was 640 million years ago. Yellowstone National Park offers its visitors a chance to experience nature at its wildest, and what could be wilder than a park sitting on top of a massive supervolcano that constantly shapes the landscape beneath it? But that does not come without consequences and accidents. Shockingly, while the Yellowstone caldera is one of the most powerful and potentially dangerous volcanic systems on Earth, it sure doesn't scare people away from visiting the park. It is not just your average volcano, it's a supervolcano, meaning if it erupts, it could cause catastrophic damage on a global scale. But that's not all. You never guess what makes it even more a topic of the sheer size of its magma chamber. Recently, scientists have collected new data, giving them a better picture of Yellowstone's underground plumbing. Right beneath the caldera, from the last eruption, sits the magma chamber. It is massive and lies just beneath the surface. If that magma were to break through, it wouldn't be a normal eruption with lava spewing out. Instead, it would release ash clouds that could blanket huge areas. And when the word blanket is used, it means it'll cover towns and even cities in thick clouds of ash. It will be like snow on a very cold winter on your roofs and on your driveways. Can you imagine it? Well, let's draw a better image. When the ash settles, it wouldn't just cause a mess, it could bury entire regions, choking crops, covering cities, and making breathing difficult. The ash in the air could block out sunlight for weeks, maybe even months, creating a phenomenon similar to a nuclear winter. The smoke and soot lofted into the stratosphere by nuclear firestorms and spread around the world by jet streams would block enough sunlight to create an artificial winter and decimate agriculture. This lack of sunlight would drastically cool temperatures, which could have devastating effects on agriculture. Without sunlight, crops would fail, leading to food shortages and mass famine. The world would be plunged into darkness, and people everywhere would feel the impact, not just those near the eruption. On top of that, the eruption could trigger earthquakes and possibly even affect tectonic plates, leading to more volcanic eruptions elsewhere. While it sounds like something from a disaster movie, probably like a rewritten script of the movie *2012*, basically zero earthquake activity in Southern California, which is very rare. Guy's an actor, he's reading a script. When they tell you not to panic, that's when you run. It's all within the realm of possibility. The scariest part is that there's no real way to prepare for such an event. It would happen suddenly and have long-lasting consequences that would reshape life on Earth for years. Even though scientists are keeping a close watch on Yellowstone, predicting when or if it will erupt is still uncertain, leaving everyone wondering what could happen if that day ever comes. We could draw instances from when it erupted in the past. The Yellowstone caldera has erupted 3 major times in its history. The first eruption occurred about 2,100,000 years ago, the second roughly 1,300,000 years ago, and the most recent one was about 640,000 years ago. These were massive eruptions, each reshaping the landscape and leaving behind the huge caldera that exists today. While there have been smaller lava flows and volcanic activity since then, these 3 eruptions are the most significant in Yellowstone's history, a park of quakes. But the painfully hilarious thing about Yellowstone National Park is that, as though people didn't have the caldera to worry about, the park is only famous for its geysers and hot springs. Old Faithful, one of the best-known tourist attractions in the United States, faithfully erupts every 60 to 90 minutes, sometimes blasting more than 8,000 gallons of water into the air. But it's also known for the frequent earthquakes that rumble beneath the ground. These quakes happen all the time, and while most of them are small, they are constant reminders that Yellowstone sits on top of something powerful. The area experiences swarms of earthquakes, which is when hundreds of tiny ones happen in a short period. These swarms can sometimes go unnoticed because they are too weak to be felt by people, but they are a signal that the underground activity is alive and moving. You're probably wondering what's causing all this moving and shaking. Well, keep watching, and you'll find out. It's the magma beneath the park shifting around. As we've mentioned earlier, Yellowstone sits on top of a supervolcano, and that magma chamber is restless. As the magma moves, it puts pressure on the surrounding rocks, causing them to crack, which triggers earthquakes. It's not necessarily a sign that the volcano is going to erupt, but it's still something that scientists watch closely because any significant changes could indicate bigger movements. You know all about the Old Faithful geyser at Yellowstone National Park, but this is even more dramatic. It's called a hydrothermal explosion, and as Les Trent tells us, you definitely want to keep your distance. Even though these earthquakes are a normal part of the geological activity in Yellowstone, they keep everyone on edge. Each tremor reminds people that there's an active volcanic system underneath, one that has the potential to cause a major disaster. For now, though, the shaking is just part of the natural rhythm of the park, keeping things interesting and reminding visitors that they are standing on one of the most geologically active spots in the world. While these swarms of earthquakes are mostly harmless, there have been stronger ones in the past with great consequences. One of the most significant accidents caused by an earthquake near Yellowstone happened in 1959. It was a summer night when a powerful earthquake hit just outside the park in an area known as Hebbon Lake. The quake was massive, shaking the ground with such force that it triggered a huge landslide. Tonight, as we continue the 60th anniversary of the Hebbon Lake earthquake, we go inside the park with MTN's Chad Lehman. Tons of rock came crashing down into a canyon, blocking the Madison River and creating what's now known as Earthquake Lake. This wasn't just a landslide, it buried parts of the area and tragically claimed the lives of 28 people, many of whom were camping or staying in cabins nearby. The earthquake didn't just affect that one area, it caused damage throughout Yellowstone too, cracking roads and sending hot water gushing from some of the park's geothermal features. Geysers erupted with more force than usual, and parts of the land shifted. It was a reminder of how unpredictable the region can be, especially with the volcanic activity beneath it constantly bubbling. Even though the earthquake and landslide were devastating, they also led to changes in how the park monitors seismic activity. Since then, scientists have kept a closer eye on the region, making sure they can track any unusual movements underground. It's all part of living with the reality that Yellowstone sits on top of a very active and sometimes dangerous part of the Earth. Today, the world was shocked by a horrific event when the caldera in Yellowstone National Park exploded. Peter Dewey's recent alert about the increasing size of the dome-shaped uplifts in the Yellowstone area has brought the ancient supervolcano under Yellowstone National Park back to the spotlight. There lies a potential catastrophe that could reshape North America. Relying on existing scientific data and the salient insights from Joe Rogan, we will examine the mysteries of the geological anomalies at Yellowstone. As the ground shifts and domes rise, could Yellowstone be on the verge of awakening, or when will the supervolcano erupt again? Yellowstone's going to blow, we're going to get hit by an asteroid, and we might nuke ourselves too. Sure, like all that stuff is real too. Join us on this exploration of the extraordinary forces that lurk under Yellowstone. We bet you don't know that the remnant of an ancient supervolcano lies under the meadows and geysers of Yellowstone National Park. Scientists agree it is so powerful that it could reshape North America in a fiery blink. More interesting is the fact that it stirs every 600,000 to 800,000 years. Recent signs have unsettled even the most seasoned geologists, a dome-shaped bulge rising simultaneously with the water levels of Yellowstone Lake. People have also observed the appearance of long fissures in the ground, sparking speculations about the potential movement of magma. The domes are scattered across Yellowstone Lake, evidence of the immense pressure and molten rock surging toward the surface. In his unconventional thoughts, Joe Rogan has provided his opinion and delved into the mysteries of Yellowstone, offering his unfiltered perspective on recent geological changes. Although his ideas are not necessarily scientific, they raise awareness about the implications of the relentless outbursts of Yellowstone. Scientists are closely watching the rising ground and fluctuating water levels in Yellowstone Lake, seeking to prove facts and dispel sensations by examining Rogan's opinions with scientific data. Through ongoing efforts to monitor the situation, we gain a deeper understanding of this extraordinary geographical anomaly. What is the volcanic history of the Yellowstone region? About 17 million years ago, the regions of southwest Idaho experienced a tremendous volcanic eruption, leaving in its trail calderas and lava flows, which is called the Snake River Plain. Today, this geographical anomaly created a path for future eruptions, eventually reaching Yellowstone. But the first colossal future eruption occurred about 2.1 million years ago, which scientists named the Huckleberry Ridge eruption. It blasted through the earth, spewing ash and debris across half of North America. The resulting caldera is now home to the famous Yellowstone Lake. Another massive eruption followed suit about 1.3 million years ago, widely known as the Mesa Falls eruption. It blanketed the region in ash and created the caldera we see today. Similarly, about 640,000 years ago, a supereruption called the Lava Creek eruption blasted, forming the current caldera and leaving behind the rolling cliffs of the Grand Canyon of Yellowstone. Geologists and scientists are still examining the impacts of these eruptions. Following these monumental eruptions, one might wonder how the people living during the period survived or whether there were no people in the region. That's a question for some other time. That's not the end of the eruptions, which continued with the formation of resurgent domes after the last supereruption. The emptied magma chamber under the caldera began to refill, creating resurgent domes. This geological process caused the caldera floor to swell upwards, giving rise to two expansive dome-shaped uplifts, the Sour Creek Dome and the Mard Lake Dome. Now, explain the resurgent domes in simple terms for better understanding. It is like a massive underground balloon filled with magma or molten rock. As the balloon expands, it exerts upward pressure on the ground above it. This process mirrors the formation of bubbles in dough during baking. It causes swelling in the ground, and they take the shape of a dome, hence the term, resurgent dome. These domes are not small protrusions in the earth. They are large, each spanning over 10 kilometers in width and rising hundreds of meters above the caldera floor. One is the Sour Creek Dome, and the Mard Lake Dome. While both domes share this common origin, they are not identical in their history or structure. The Sour Creek Dome, for example, grew above the adjacent caldera rim before its growth halted. Several faults mark its surface. These cracks formed when the dome exerted pressure against the surrounding rock. On the other hand, the Mard Lake Dome protruded upwards and underwent substantial resurgence approximately 170,000 years ago. Joe Rogan has shed light on the concealed threats and the potentially catastrophic impact of these giant domes. Rogan argues that the eruption may already be underway. In one of his episodes, the fact that such a colossal force of nature might have set in motion is extremely terrifying. Rogan's arguments remind us of the force under our feet and the potential for an eruption that could reshape regional and global geography. Furthermore, Rogan expresses concerns that we might have underrated the dangers lurking in Yellowstone. What geological discoveries have been made in the Yellowstone area? While the immediate vicinity of Yellowstone National Park may appear serene, experts have warned that under this beautiful space lies a slumbering giant, the Yellowstone supervolcano. This volcano's potential to unleash cataclysmic fury has long captivated Joe Rogan, the outspoken commentator who continues to sound the alarm. The concerns expressed by Rogan are in tandem with recent scientific discoveries. Scientists working around the clock to monitor the Yellowstone caldera have been amplifying the need for us to prepare for the inevitable. These scientists also made a shocking discovery. They found a dome-shaped uplift within the volcano system. This revelation emerged from the works of Dr. Robert B. Smith of the University of Utah. Smith also discovered that water levels in different parts of Yellowstone Lake were not uniform, suggesting the entire lake basin tilted like a seesaw. This wasn't just a gentle sway, it was very monumental. Imagine a shallow pan filled with water. As you tilt it slightly, the water rushes to one side, exposing the other. Something powerful hidden below was pushing upwards, reshaping the ground and consequently the water above. This seemingly minor discovery sent shock waves through the scientific community. It wasn't just the ground around the lake, the caldera was actively deforming. This discovery, as documented in the USGS film, Inside Yellowstone, confirmed Rogan's warnings about the restless supervolcano. Dr. Robert Christensen and other geologists have called this dramatic rise of the land spectacular. Two factors were generally suspected: magma, the molten rock pulsing under the Earth's crust pushing its way toward the surface, or the vast hydrothermal system of the park, a network of hot water and steam expanding and flexing the ground. Both possibilities point to a stark reality: the magmatic system under Yellowstone was not lying dead but actively shifting and reshaping the land in ways that could suddenly become visible. The tilting lake shows the need to continuously monitor and understand the delicate dance of the geology of Yellowstone, a mix of breathtaking beauty and the potential fury of nature below. The task of monitoring ground deformation has been ongoing for some years. Fortunately, it has recorded significant evolution in recent years as modern techniques and advanced technology have been deployed. Today, scientists rely on GPS and InSAR to detect even the slightest movements. This evolution in monitoring techniques shows the progress made in geology. It helps to achieve more precise and comprehensive observations of ground movements at critical locations like Yellowstone. These methods represent a quantum leap from past techniques, involving signals from satellites orbiting the Earth to meticulously track how the ground shifts, swells, or sinks. In earlier times, geodesy, the branch of science dedicated to understanding the shape and variations in the Earth's crust, was the primary tool for studying deformation. Geodesists employed a meticulous technique known as leveling to measure vertical deformation, capturing both the rise and fall of the ground. While using this system, surveyors are armed with leveling instruments and graduated staff. They meticulously measure elevation differences between fixed points called benchmarks, repeating the process across a vast network over time. These meticulous measurements built a detailed map of the ground's shifting contours. A leveling survey was first used in Yellowstone in 1923. Remarkably, some of those original benchmarks remain there today. They are marked with anchors, and more than 500 such anchors are still standing. In 1975, an earthquake forced scientists to make another survey, which revealed a shocking reality: the caldera had dramatically uplifted approximately over 28 inches since 1923. This unexpected surge averages 1.4 centimeters per year and far exceeds the earthquake's impact. This made scientists suspect that a deeper process was driving the swelling of the ground. When scientists mapped the changes between 1923 and 1975, you will be shocked by another striking discovery they made. The most dramatic uplift occurred between two key areas: the mysterious depths of Mary Lake and the waters of Sour Creek. This pattern throws light on the potential source of the swelling and a hidden force lying under the park's surface. While leveling offered salient results, it was laborious and limited. Today, sophisticated tools like GPS and InSAR provide a continuous high-resolution view of the restless heart of Yellowstone, but the legacy of those early surveys remains evident of the dedication and ingenuity of past researchers who laid the groundwork for our understanding of this supervolcano. However, in 1985, a shift occurred as an earthquake near the northwest edge of the caldera gradually sank the rising ground back into Earth, a process referred to as subsidence. Scientists believe that fluids such as magma, hot water, and steam, which had been building up pressure under the surface, started to leak out of the caldera. This release of fluids alleviated the pressure, causing the ground to rise. Starting in 1995, the behavior of the caldera floor became even stranger. Parts of the floor began to rise while others continued to sink. Scientists also observed that all these geological anomalies are intricately connected. It became evident that these tremors and shifts were not isolated events but interconnected pieces of a larger, more menacing pattern. Recently, another chilling revelation surfaced in the vast wilderness of Yellowstone Park. On an ordinary day near the Hidden Falls in Grand Teton National Park, guides noticed a gigantic crack about 100 feet high and over 300 feet long, and it seemed to have appeared overnight. The discovery of this massive crack, now known as the Hidden Falls Fissure, sent a shiver through the scientific community and the public alike. Nature is truly unpredictable. While fissures like this can be alarming, it is not entirely unexpected in such a volatile area. However, its proximity to the massive Yellowstone volcano has raised concerns to a new level. When will the supervolcano erupt again? Although the last time a supervolcano erupted was approximately 630,000 years ago, the question remains not if, but when it might erupt again. The gigantic magma chamber under Yellowstone suggests that powerful volcanic activity still lurks underground. When the eruption occurs again, we can expect catastrophic consequences that would have far-reaching impacts, not just in the immediate vicinity, but potentially on a global scale. Isn't it surprising that Yellowstone National Park sits on top of a massive supervolcano, one of the largest and most dangerous in the world? Scientists estimate that when this volcano erupts again, it will unleash a devastating force unlike anything witnessed today. We can expect to see large volumes of ash ejected into the atmosphere. Unlike the soft material associated with fireplace ashes, this volcanic ash is more like fine, abrasive sand. As it falls from the sky, it would blanket the area and cover everything in its path with a thick layer. The immediate impact of ashfall would be a logistical nightmare, with roads, railways, and airports shut down, making transportation nearly impossible. People in the affected areas would need to shelter indoors to avoid inhaling the abrasive ash, which can cause respiratory problems and damage heavy machinery. However, that is not all about the consequences of ashfall. It can also lead to the collapse of roofs under the weight of the accumulated ash, disrupting power supplies and causing structural damage to buildings. We must also talk about the invisible threats, gases, acid rain, and a potential volcanic winter. All these suggest that the devastation would be too bad to watch. One of the key gases to watch out for is sulfur dioxide. This gaseous menace, spewed in vast quantities during an eruption, reacts with water vapor in the atmosphere to form sulfuric acid aerosols. These microscopic droplets descend as acid rain, unleashing havoc on the environment. Water becomes contaminated, aquatic life suffers, and our drinking water sources become highly toxic. Vegetation will also wither under the corrosive rain, infrastructure will crumble, and the air will become a hazard to human and animal health. So, the potential danger is ecological, but also social and economic. Some experts believe that the most terrifying consequence is a volcanic winter. The massive ash and gas plume thrown into the atmosphere could shroud the planet in a dense, sunlight-blocking veil for months, even years. This sudden plunge into darkness will trigger a global cold snap of epic proportions, with temperatures plummeting and crops failing. The fallout of this volcanic winter would be nothing short of catastrophic. It would be like a nuclear explosion. Food shortages and famine will become new realities, with the fabric of societies dependent on agriculture destroyed. A struggle for survival will take center stage. The problem would not be limited to finding food. Maintaining warmth and basic living conditions in a darkened, freezing world would be a monumental test of human resilience. Yellowstone remains one of the most monitored locations by the United States Geological Survey. Some scientists also predict that the prelude to an eruption might be shorter than imagined. This revelation means we may have a limited window to plan for evacuation, resource allocation, and disaster preparedness. Imagine the scramble. Sirens shriek as volcanic clouds paint the sky. Millions flee in a tide of fear and uncertainty. Resources, even though meticulously planned, could suddenly become woefully inadequate. Every decision takes on life or death weight. The Sour Creek and Mary Lake domes will be areas of particular interest. These areas are likely weakened by past volcanic activity, and they will therefore become focal points for the upward pressure of the magma, causing the ground to swell dramatically. But why doesn't this internal tug-of-war always lead to eruption? The answer lies in the magma and the surrounding rock. Yellowstone's magma is often rhyolitic, a thick, sluggish variety prone to trapping gas. This trapped gas can build pressure, potentially leading to explosive eruptions. However, if the magma finds a way to release this pressure gradually, like subtly pushing through weak spots in the earth, an eruption may be averted. The surrounding rock plays a key role as well. If it is strong and flexible enough to bend under the pressure, it allows the dome to form, acting as a pressure valve. But the magma may find a more explosive escape route if the rock cracks and fractures. This interplay between the uplift of the dome and volcanic activity shows the delicate balance under Yellowstone. That is not all. These rising domes are clear indicators of a restless magmatic system. They signal magma accumulation, potential seismic activity, and shifts in the hydrothermal system. On the other hand, they can also serve as a safety valve, allowing pressure to be released gradually and potentially preventing a larger eruption. Understanding the rate and extent at which the dome shifts up is important for deciphering the current state of the volcano and predicting its future behavior. By meticulously monitoring these bulges, scientists gain invaluable insights into the hidden forces churning beneath Yellowstone, allowing them to assess the likelihood and nature of potential eruptions. Every minute spent studying Yellowstone, every dollar invested in monitoring, and every conversation about potential scenarios is a step toward mitigating the chaos. We can't control the dragon, but we can prepare for its dance. Do you think the next Yellowstone eruption is imminent? We would love to hear your views in the comment section.